You know, when you walk into like a massive sports bar on a Sunday, you see this giant wall of glowing screens.
Oh, yeah. Football on 5 TVs, racing on another one,
Mhm.
basketball in the corner.
Exactly. And then seamlessly, all the screens suddenly just switch to the main event.
Right. All at once.
Yeah. And we just sit there, watch the game, drink our beer, and we're totally oblivious to the absolute chaos of data routing happening right behind the wall.
It really is chaos back there.
Okay, let's unpack this, because today on this deep dive, our mission is to figure out how that magic actually happens.
Yeah, it's a great topic.
We managed to get our hands on the technical spec sheet for the WolfPack Fast 8x16 HDMI matrix switch. So we're going to use it to uncover how these huge commercial venues wrangle massive amounts of video data without a single glitch.
Because, I mean, the scale of what's happening in those back rooms is just wild. You know, you can't just plug 15 cable boxes into a giant splitter and call it a day.
Right, that would be a nightmare.
Exactly. So a system like this WolfPack, it uses an 18 by 18 chassis. Basically, it's a giant grid where literally any video input can map to any output.
Okay.
And right now, the specs show it's currently configured with 8 input cards and 16 output cards.
And these aren't just like fixed ports soldered directly to a motherboard, right? They're individual modular slide-in cards, kind of like server blades, or actually kind of like replacing a single burnt-out bulb on a string of Christmas lights rather than throwing away the entire wire.
That is a perfect analogy, actually. Yeah, they're totally modular. And the most critical aspect of those one-port 1080p cards is that they are hot pluggable.
Wait, I want to stop and look at that hot pluggable feature.
Yeah.
Because with regular home electronics, if you rip the circuit board out while the power's on, I mean, you're going to instantly fry the system.
Oh, absolutely.
So how does a massive commercial matrix survive that?
Well, it's all about isolated power and data paths. When you slide a card out of this chassis, the system is designed to instantly sever the connection to that specific slot.
Without taking down the rest of it.
Right, without interrupting the main data bus at all. It's kind of like changing a tire while the car is still driving down the highway.
Wow.
Because you have to think about the commercial application, you know? In a live environment like a packed sports bar, a dead screen means you're losing money.
Yeah, people get mad.
Exactly. You can't afford to power down the whole system or, God forbid, send the massive matrix unit away for a 2-week repair. You just slide in a new card and keep pouring drinks.
That makes total sense.
They even include dual power supplies that just automatically switch over if one of them dies.
Okay, so the hardware is basically built like a tank. But anyone who has ever switched inputs on their TV at home knows about that awful, like multi-second blackout delay.
Oh, yeah. The worst.
Right. You hit HDMI 2, the screen goes black, sometimes it flashes static. Doing that across 16 screens in a crowded bar would look terrible.
It would. But what's fascinating here is why that blackout happens on your home TV in the first place, and how this matrix actually prevents it.
Okay, why does it happen?
Well, that standard delay is actually a security feature. Every time you switch inputs, your devices are executing an HDCP handshake. It's basically a real-time copyright check to ensure you aren't, pirating the signal.
Ah, okay. So the blackout is just the TV and the cable box negotiating with each other.
Right. But this matrix boasts 100 millisecond instant seamless switching. It pulls this off using what they call an ED-booked ghost unit.
A ghost unit.
Yeah. EDD is just the data that tells a source what kind of display is connected. So the ghost unit basically fakes that data. It constantly tricks the table box into thinking it's actively displaying something.
Oh, I see. So when you actually switch to that feed, it doesn't have to renegotiate from scratch.
Precisely. It executes those copyright handshakes simultaneously in the background, and it uses a frame buffer to hold onto the video signal instantly, so you never get snow or weird purple color spaces.
Yeah.
You just get a perfectly clean frame-to-frame cut.
Here's where it gets really interesting for me, though. I was looking through the control specs to see how a bartender actually directs this massive beast, and I noticed it doesn't even come with a standard IR remote.
Right, which seemed weird at first. But think about where this unit actually lives.
In a closet.
Yeah, it's locked in a dark, noisy AV closet in the back of the restaurant. An infrared remote needs a direct line of sight to function.
So it would be entirely useless.
Useless, yeah.
Makes total sense. So instead, you control it over the network via mobile apps or a web GUI. But it also relies heavily on an RS-232 serial interface.
Which is such a throwback.
It is. For anyone who hasn't tinkered with older tech, RS-232 is this super reliable old-school communication standard. You basically use it to send basic text commands directly to the hardware. And it also supports embedding and de-embedding separate 3.5 millimeter audio.
And the command language they use for that serial connection is brilliantly straightforward.
It really is. Like if the user wants to switch input 8 to outputs 1, 8, and 16, the command sent is literally just by 1 and 8 and 16 with a period at the end, just typing those numbers.
Yeah, and if we connect this to the bigger picture, that simplicity is incredibly empowering. Commercial venues usually run massive third-party automation systems.
Like Control 4.
Exactly, like Control 4. Because the RS-232 commands are so basic, the venue owner doesn't have to hire an expensive software programmer to make it work. Any local installer can just plug those simple commands into the automation system themselves.
Which could save them thousands of dollars.
Easily.
So what does this all mean for the venue owner? Basically, for a $3,550 investment, a venue gets a bulletproof, highly customizable routing grain that keeps the screens flashing and the crowd happy.
It's pure practical engineering.
It really is. But it leaves you with a really fascinating question to think about. Because this unit relies so heavily on physical modular hardware, I mean, literally down to tiny physical 8-pin DIP switches on the circuit boards to control video scaling.
Yeah, very tactile.
Right. So as video resolutions inevitably surge past current standards, from 1080p to 4K, 8K, and beyond, will massive metal hardware matrices like this remain the gold standard?
It's a good question.
Or will the industry eventually abandon these metal boxes entirely, routing all this heavy AV data through pure cloud-based software solutions? Something to chew on next time you're staring at that glowing wall of TVs. Are you looking at the pinnacle of hardware or a ghost in the machine?